Welcome back to another AddMaths tutorial video where today I'll be covering Form 4 Chapter 3, Systems of Equations. Alright, so today we're going to be covering Chapter 3, which is Systems of Equations. So basically the types we're going to be looking into are system of equations which include three variables. So in this case it will probably be x, y and z as unknowns. Or we're going to be looking into system of equations which include one linear equation and one non-linear equation. Basically those are coefficients with unknowns as xy or 1 over x or x with powers higher than 1 basically. Alright, so let's say you've been given three equations which have three variables x, y and z. So first thing you want to do is to actually label these equations as equation 1, 2 and 3 for to make your working easier. So I'm going to be using elimination method since it's way faster. Since we're working with three variables, substitution method would be quite tedious and quite slow. So what am I going to do? I want to make it to where only two variables, only one variable are left. So let's focus on z actually. I can make z disappear. Maybe I can times equation 2 by 2 to make 1 and 2 disappear, right? And then maybe I can then times equation 2 and 3 by 3 and by 2 so that I can make them disappear. Alright, you'll see what I mean when I do the working. So let's say, alright, I'm going to do equation 2 times 2, which will equal to 6x plus 6y plus 4z equals a negative 6. Don't forget to times what is on the right side, alright? And then I'm going to bring back down equation 1 over here. So that's going to be 5x minus 2y minus 4z. So as we can see, both coefficient of z equals to 4. That means I can make both of them disappear, right? So I will just, since it's plus minus, I'll just be adding. So I'll be left with 11x plus 4y equals to negative 3. There you go. That's the first equation that we found. So I'm going to call that equation 4, right? So next one, I can use 2 and 3. So I'm going to do equation 2 times 3. So that one I'm going to get 9x plus 9y plus 6z equals negative 6. And then I'm going to do equation 3 times 2, which is going to be negative 4x plus 10y plus 6z equals to 6. So from here we already see what we're going to do next, alright? I want to make 6z disappear. So since they're both positive, I got to subtract. So with that, I'm going to get 13x. I'm going to get minus y equals negative 6 minus 6 as negative 12, right? Alright, wonderful. Oops, looks like I made a mistake over here. It's supposed to be negative 9, right? Negative 9. Negative 9 minus 6 should be negative 15, right? Let's see, negative 3 times 3. Alright, just gonna check. Always check your equations. You can always get really careless mistakes doing this kind of questions, but you just gotta take it slow. Alright, so now I got my equation 4 and my equation 5. Let's make it to where I only find one answer. So let's bring it down. I'm gonna get equation 4 as 11x plus 4y equals negative 3. And since I need the y to have the same coefficient, I'm going to do equation 5 times 4. So I'll get 26 52x minus 4y equals to negative 60. So now I just have to add. Since it's plus minus, I'm going to get 63x equals to negative 63. Therefore, therefore my x equals to negative 1. Alright, so now I just have to find y. I'll just sub it into, let's say I'm going to sub x equals negative 1 into 5. So I'm going to get so I'm going to get 13 negative 1 minus y equals negative 15. So it's negative y equals to negative 13. Bring over there, it's going to be negative 2. Therefore, y equals to 2. Now, how are we going to solve z? I recommend just taking the easiest equation over there. Let's say equation number 2, right? So that's going to be 3x plus 3y. Let's do it down here. So we're just going to do sub x equals -1 and then y equals 2 into equation 2. So that's going to be the same as 3 bracket -1. What was it again? 3 bracket -1 plus 3 bracket 2 plus 2z equals -3. So I'm just going to do this quickly. 2z equals to -3, 6, 3, bring over there. You're going to get about 2z equals -6. And therefore, we're going to get the answer z equals to -3. Simple way, quickly, that's how we're going to do systems of equations. Alright, so now let's do system of equation question with a nonlinear equation. So you've been given these two equations again. Let's just label them as 1 and 2 like we always do. Alright, now then, as we can see, our equation 2 involves a quadratic version of the unknown y, which is y squared. So basically, when we answer these kind of questions, we have to use substitution method. We have to use them because it makes it way faster and easier. Since you can't use elimination method because there are coefficients of unknowns with different powers. So in this case, I want to sub in 1 into 2. Because if you were to sub in 2 into 1, it will be kind of complicated since you have to use work with y squared. But vice versa, you can actually use whichever way you want. In this case, I'm going to use method 1 since x doesn't have a coefficient, so I wouldn't have to divide anything. So let's do it. So x plus y minus 12 equals 0. I want to sub 1 into 2, so I'm going to have to sub something into the x over there, right? So I have to make x a subject, which is x equals to 12 minus y. So now then, I can sub into equation number 2, right? So it'll become y squared minus 8 bracket 12 minus y equals to 9. From there, I can just continue y squared minus 96 plus 8y. I'm going to bring the 9 over straight away. Minus 9 equals 0. So let's rearrange this as if we're solving a quadratic equation. Negative 96, we get negative 105. Don't worry about the big number. It's just another factorization. Just use our calculator. Basically, you're going to get y plus 15 and also y minus 7 equals 0. Therefore, y equals negative 15 or 7. Now then, that's not the end of it. Basically, since we have 2 answers for y, there are going to be 2 answers for x. So then, let's say when y equals negative 15, now I'm going to sub the values I found into this equation since it's going to be easier. So I can say when y equals 15, negative 15, x equals to 12 minus negative 15. So plus is going to be x equals to 27. And then when y equals to 7, I'm going to do the same thing. X equals to 12 minus 7. So I'm going to get x equals to 5. Oh, so one more thing I forgot to cover when I was doing the 3 variables question is when you finish finding your answers, always relabel them. Point it out what is your answer, as in by writing therefore x equals to 27, y equals to negative 15, or x equals to 5, y equals to 7, so that you can show your examiners clearly these are the answers that you found. Alright, so let's go through some tips. Number 1, always label your equations. So it'll be easier when you're trying to prove or you're trying to write your equations. It's always nice when you're working, basically. Number 2, always use the therefore. You gotta show your answer. X equals whatever, y equals whatever. Use the or, for your quadratics. Basically, you just want to restate where your equations are. It makes your answer look prettier, easier for the examiner. And lastly, and most importantly, take it slow. Systems of equations is a very easy topic, but it's also very difficult and tedious. Sometimes when you start doing harder versions, like for example, maybe when you're answering a system of equation with a non-linear equation, you might have to use the formula method. You might have to use CTS method rather than just factorization. So you have to be careful. It might look easy, but if you don't remember the basic of, like the formula of negative b plus minus, it's not going to be easy. So you just have to try your best doing these kind of questions. Take it slow. Alright, thanks for watching the video. Please look forward to the next ones. Ciao, Lu.